Greetings, everybody, and welcome to Introduction to Generative Technology, AI in K-12 Schools. This Hawaii Professional Development course is sponsored by the Hawaii Education Association and is being offered in the summer of 2024 for Hawaii educators and hopefully for additional attendees in the fall and spring. My name is Frederick Lane. I am the author and presenter of this program. It's a real honor for me to have a chance to do that over the coming weeks, and I look forward to working with everybody on this program. I am a Brooklyn, New York-based attorney and writer and lecturer. I've had the privilege of visiting Hawaii a number of different times and talking with educators and administrators across the state. So I think we're going to be able to do some really good work in terms of helping people to understand what generative technology is and what it can offer for educators, as well as some of the potential risks or issues that people need to be aware of. Just one general piece of information is that I'm on the road a fair amount over the next few weeks. So there'll be a variety of different backgrounds for me when I'm doing these presentations, and occasionally random background noise, but hopefully that will not be too bad. So let me give you a little bit more background about me and my work, and then we'll plunge into an introduction of the general structure of the course, and then we'll also be talking about some of the important basic concepts of generative technology that you're going to be encountering very quickly over the first week that we dive into this material. So for those of you who don't know or haven't had a chance to attend any of my lectures, I spent 25 years in Burlington, Vermont. 10 of those years I spent on the Burlington School Board working on a variety of different issues, including technology, finance, and then eventually chairing the board as a whole. It was obviously a tremendous opportunity to really see how schools function at a variety of different levels. My kids were going through it at the same time, so I was also interacting with the school as a parent, but certainly having a chance to work as a board member and understand the various policy debates and concerns that arise with respect to technological issues, financial issues, and so forth has been enormously helpful in giving me some grounding for the kind of material and presentations that I provide to educators. Over the course of the last decade or so, I've been working on a series of books under the heading Cyber Traps. The three most recent, actually one of which doesn't use the word cyber traps, but you'll get the idea. The three most recent are Cyber Traps for Expecting Moms and Dads, which is about the various technological issues that people should consider when they're having children. Raising Cyber Ethical Kids, which is a look at the different conversations that are useful to have with your children as they hit different development stages in their childhood. And then most recently, Cyber Traps for Educators 2.0, which goes over a variety of the different digital risks that can pop up thanks to technology, and obviously thanks to the incredible amount of time that kids spend using technology and the interaction that they have with their classmates or with members of the school faculty. So this book is actually in the process of going under a fairly substantial rewrite for version 3.0. That actually has been slowed down by the onset of artificial intelligence or generative technology, because the implications of that really touch on all of the different topics that I covered in Cyber Traps for Educators 2.0. So let's talk a little bit about how this course will be structured over the next 6 to 7 weeks. I would strongly urge people, if you have any questions about the course, the general approach that I'm taking, or specific aspects of it, please reach out to me by email. Obviously, you can do that through the PDE system, which has a link there to email me directly, or you can just email me at fslane3@gmail.com, and I will be sure to get back to you and answer whatever questions you might have. The basic structure is as follows, that we are going to be doing 4 different modules, basically each module lasting roughly 7 to 10 days, depending on the schedule for recording and so forth, and whatever developments may arise. But the concept is basically to break down this introduction to generative technology into 4 areas. So first, an introduction to the technology to give folks a grounding in the terminology, the major players who are involved in the development of generative technology, and some of the some of the things that we might anticipate looking at over the next few weeks, just because there are some real clear trends that are starting to emerge in terms of what is going to happen with this technology. Once we have covered the basics and we've given people the information they need to better understand what's going on, then I'd like to turn our attention to helping people develop systems for keeping up to date with this. And it's not in any way anticipated that you're going to make generative technology a significant portion of your substantive or core research, but there's little question, I think, that generative technology is going to have a fairly significant impact on classrooms in general. And so if you've got some well-developed mechanisms for following some of the developments in the field, and more importantly, for tracking new sources of generative technology information about classroom applications, then I think it will really be a lot easier for you to figure out which of them might be useful, what some of the concerns might be, or alternatively, coming at it from a slightly different angle, helping you to understand what your students are doing, because they're going to be persistently pushing the boundaries of how this technology gets used, and often without having any thought or any concern about what the ethical or intellectual honesty implications might be of what they're doing. So ideally, at the end of that second module, you really have some fairly well-established procedures for making sure that you get alerts that you're up to date on specific developments. Once we've done that, then I think it's worthwhile in terms of an introductory course to spend a reasonable amount of time discussing the ethics of generative technology. In the first place, really, to approach that is with respect to students, because that has been one of the most significant concerns that has been, if you will, generated by this technology, because it has made it very easy for students to accomplish various assignments in ways that don't necessarily reflect their capabilities, their abilities as students, and it's made the whole assessment process of this much, much more complicated. This is actually something that I live with on a regular basis, because my wife is a professor of art history at the Fashion Institute of Technology here in New York City, and it has been something that has driven her really up the wall over the past year, trying to figure out what is necessary in order to restructure her courses and change the assessment method so that she's getting some reasonable idea of what the students are actually learning. I mean, her big pitch on all of this is, I am not going to give out grades to bots, because that's not my job. My job here is to give out grades to students and to have some sense of what the students have actually learned. And this is one of the fundamental questions that education as a whole is grappling with, and we will certainly be looking at that, particularly in this third module. And then in the fourth module, I think it's going to be really worthwhile for educators to basically hold a mirror up to themselves and start to really think about how you might use this technology and what are some of the implications in how you choose to do that. So we'll be talking about some issues like student privacy, we'll be talking about copyright, we'll be talking about intellectual property. I want to be absolutely clear. I am not a Luddite about this technology whatsoever. I think there are tremendous benefits that can be derived. Certainly, there's a lot of repetitive work within every teacher's life that generative technology and its cousins, depending on how you want to define all that, can help with, can really smooth the process, make things go a lot more quickly. It's always a question, though, of have we thought this through in terms of what some of the implications are? Is there transparency about how these technologies are being used? And is there, I think, reasonable awareness on the part of the administration that they're being used? Because they're going to be the ones fielding questions from students, from parents, from anybody else who might be concerned about the fact that you may be using one or more of these generative technology tools. So that'll be the final portion of this particular course. And I think there'll be some really fascinating, really engaging questions throughout, but particularly those that deal with the ethical debates, because they're, ethics is in some ways at the core of our humanity. And there's no question that the capabilities of these new software programs are bumping up against that. And we're going to have to figure out as a society and as an educational profession how we're going to deal with all of that. So within each of the three modules, and if you've had a chance to go through the syllabus, you've already got a reasonably good idea of how this is shaping up. Within each module, we're going to have three components. Number one, establishing objectives for that particular module. You can see those with all four modules right now in the syllabus. There are going to be specific activities for each module. Typically, those will be broken down into the viewing of a video such as this, and then also reading materials, background materials on the various points within the module that I think are important. A handful of videos typically drawn from things like TED Talks or what have you that I think are helpful in providing different perspectives on the material that I'm talking about. And then in each instance, I'm also going to try to have what basically now I realize I should rename as a newsroom, which will be a handful of articles drawn from the most recent sources that talk about the specific aspects of what we're dealing with. And part of the reason for including that, even though some of those will fairly quickly get dated if you go back and look at this, is that it will help to illustrate for you how much coverage there is, number one, of all of these different topics, and then secondly, how fast everything is moving. And that's going to be just an ongoing theme for this course, that there will be developments during the time that you're enrolled in this that we can't even really foresee. There'll be new tools rolling out literally on a day-by-day basis. And we're not going to try to keep up with everything, but we'll basically be taking snapshots of these various developments within the specific modules that we're looking at. And hopefully that will give you a good framework for going forward once the course is over and maintaining a certain familiarity with everything that we're talking about. And then lastly, obviously, for the issuance of professional development credit in Hawaii, there needs to be learning portfolio output that the DOE can take a look at and assess as to whether or not it meets their criteria for the purposes of issuing professional development credit. So I've started to put together my description of what those outputs should look like, and I would very much encourage people to send whatever drafts they have as they're working on these things over the next 4 to 6 weeks, so that I can offer feedback as we're moving through this process. I am going to double check on this, but in response to one question, I was reminded that regardless of what software you use to prepare your learning output, it could be Microsoft Word, it could be Google Docs, it can be Canva, whatever it may be, just bear in mind that the ultimate submission to the DOE has to be in PDF format, And there also needs to be a caption attached to each individual project with explanatory text. And you'll see more of that emerging in the syllabus as I start to really hone what I'm looking for and what I think will produce good professional development credit worthy material for the DOE. To be perfectly frank, this is the first time that I've taught a professional development course in the state of Hawaii. So there will certainly be a learning curve for me as well, and I encourage people to give me suggestions and feedback from me with respect to any of the output assignments so that we can make sure that everybody is shepherded through this process as smoothly as possible. Within the activities, as I said, I've already gone over this a little bit. There'll be the PowerPoint, there'll be the reading materials, relevant videos, recent news articles. So that's all pretty straightforward. Another thing I'll certainly encourage people to do, you'll be going through and doing your own online research as this course progresses. Do not hesitate to send me things that you personally found useful or helpful or that you think might be valuable to other members of the class. I really want to treat the syllabus as a dynamic, organic document that we can add to. Obviously, with respect to future iterations of this course, much of the material will have to be stripped out for newer material that reflects different developments. But for the purposes of our next 4 to 6 weeks, please do not hesitate to pass things on to me, and we'll throw them on there if they look like they might be useful. So let's move into just a brief introduction to generative technology and some of the basic history and then terminology that's relevant for all of this. And then we will go forward and start digging into the substance. So really the fundamental question that we are grappling with, and this is a long-running discussion and concern in humanity, is whether or not we have the capability to create artificial life. And in a way, it's kind of a funny question because obviously we are so capable of producing life in a biological fashion, but the question I think becomes, and this is where philosophy really bumps up against all of this computer technology, the idea of whether or not we can, as human beings, control the reproductive process from start to finish. And I chose here, this wonderful pizza oven that I built a few years ago because this was capable of an actually incredible temperature for making pizzas in the backyard in Brooklyn, which was, by the way, highly illegal. But in any case, the idea of fire, very much the mythology of Prometheus, that this was really the spark that lit humanity, was when Prometheus stole fire from the gods and brought it to humanity. And so as punishment for that, he was chained to a cliff and condemned to have an eagle tear out his liver every night, and then it regrew overnight. I mean, the Greeks had absolutely marvelous punishments that they decided upon. But the reason that Prometheus is such a wonderful starting place for this is because the reason that Prometheus and the origin of fire for humanity is such a useful starting place for this particular discussion is that over 200 years ago in 1818, when Mary Wollstonecraft Shelley wrote her book about the reanimated monster that we know as Frankenstein, the actual title of her book was Dr. Frankenstein, or the Modern Prometheus. And her point, which she takes several hundred fairly long pages to make clear, is that she felt that Dr. Frankenstein was tempting the gods or toying with the gods in the same way that Prometheus had in terms of trying to usurp their powers and their capabilities, and that it was basically hubristic and beyond the reach of humanity to do that. I would encourage anyone who hasn't seen it to go out and stream the much funnier but equally thought-provoking Young Frankenstein from 1974, which is absolutely one of my favorite films, and I think offers us some really amusing insights into this question of to what extent can we develop or create artificial life in some way. The really fascinating discussion that arose with respect to all of this comes from the mind of one of the most brilliant computer scientists in the 20th century, a young man by the name of Alan Turing. And again, because I'm a big media fan, if you haven't seen it, I do highly recommend The Imitation Game, which is about the role that he played during World War II at Bletchley Park in developing a advanced machine, something that nobody had really conceived of before, to break the German code machine known as Enigma. And Enigma was routinely considered to be absolutely unbreakable. But Turing had the idea that not only could you use a machine to basically decrypt what another machine was doing, but that it was also possible to create what he referred to as a universal machine. That is to say, a machine that could be programmed not just to solve the problem of German submarine codes, but more importantly, to basically solve whatever problems it was programmed to solve. And there's a huge debate, of course, about every scientific development, but when you are listing the people who came up with the idea of the general purpose computer and offered very concrete ideas about how it should be developed and implemented, Alan Turing is absolutely near the top of the list. The other thing that was really significant about Turing, and you'll see this phrase popping up with some frequency with respect to the generative technology that you'll be reading about, and that's this idea of a Turing test. And what he basically was arguing or suggesting was that if we could get to a point where someone is interacting via desktop or some other terminal with another entity, and the person engaging in this experiment cannot tell whether the other entity is a computer or a human based on the answers it gives to questions, then is that machine actually, or can we say a computer is then capable of thought? And when you start playing around with some of the different generative technology tools that we'll be dealing with, and you start asking it to do things, and many of you I'm sure have already done this, the responses that you will get seem remarkably human. And that, of course, is precisely the point. But is it really conscious? Is it actually thinking? What I think this may be one of the real limitations that actually popped up for Turing was that he did not necessarily anticipate that we would develop tools and technologies that would let us imitate humanity without necessarily being capable of independent thought. And that's, I think, just a fascinating aspect of where, the technology of his time was inherently limiting in terms of what he was able to foresee. Again, if you've seen The Imitation Game, or if you've read the book on which it was based, then you know the very sad coda to his life, which was that he was gay, and under the laws of Britain at the time, that was a criminal offense. And so in 1952, he was given the option of either imprisonment or chemical castration. And after 2 years of taking the medication, wound up committing suicide. So just I think a tremendous loss to us all in terms of what the potential innovations and insights he could have offered. What makes it really fascinating is that as computers developed in the post-war era, we really began to confront this issue of whether or not the devices that we were building could become sufficiently sentient, could become sentient merely as a function of how complex they were. And this is going in parallel, incidentally, with the neurological study that people have been conducting over the last half century or more, in which there's a real attempt to understand the incredibly profound complexity of the human brain. And so when you go back into the archives, for the 1950s, 1960s, one of the most common phrases that you would stumble across when you're researching this kind of stuff is quote unquote electronic brain. And that was obviously the simple analogy metaphor that was being used in an attempt to help people understand why it was, for instance, that a UNIVAC computer could calculate election results quickly enough to predict in 1956 who was going to win the presidential election that night. The irony was that the computer's prediction was so contrary to predictions by experts that the experts told the programmers that they had to be completely wrong. And it turned out, some 10 or 12 hours later, when the results really came in, that the computer had been spot on. So you're starting to see this tension already about the capabilities of a machine adequately programmed to come up with results that are counterintuitive and not necessarily acceptable to the perceived wisdom of human experts. So these tensions have definitely been around for a long time. And I think that we're going to start seeing that amplified by the ways in which generative technology appear to be replacing some of the kinds of activities that humans do. And that, I think, is the overarching question that we're confronting is, what impact is this going to have on society, and how do we regulate that impact in ways that will allow, number one, society to keep functioning in a proper way, but also will still provide opportunity for the students who are going through your schools right now. A little bit more in terms of the computer technology and so forth that we're dealing with. It didn't take long in terms of the late 1950s for people to start speculating about not just whether or not a computer could fool someone into thinking that it was human, but what tools it would use to do that. So, it's worth noting that in the early days of computer development and computer programming, if a computer was going to provide output to a user, it could only do so if that output was included as part of the actual programming of the device. So, for instance, if you were doing a really low-level basic program, which is about as far as I got in programming myself, and you were counting the number of cars that were going across a bridge or something like that, those words, bridge, trucks, cars, autos, whatever, would actually be part of the data that you would put into the program itself. And depending on the results of the calculation, the computer would choose those words and spit them back out as part of the answer. The key development, I think, is that people began to work on ways in which computers could start to view language itself as data that was being input to it, and then could use that data to provide a range of different outputs. So the best example of that arose in 1972, when you had programmers playing around with the idea of therapists, basically. The idea that people would sit down at a computer terminal and they would start interacting in a very basic way, no pun intended, with the computer about how they were feeling, their emotions, their concerns, and so forth. So Eliza was the first of these. She was actually programmed, or the program was written in the early to mid 1960s. Incredibly simple ideas. So basically, if you sat down at a terminal and you were playing with the Eliza program, you would type in, "I feel sad today." The program would spit back, "Why do you feel sad?" "My dog died." "How did your dog die?" Or "How did it make you feel when your dog died?" These kinds of things. I mean, it's just picking up on random keywords. A few years later, somebody ended up doing this slightly more sophisticated version called Perry. One of the fun things was at this computer conference in 1972, they actually set these two programs up to therapeuticize each other, which is it's really kind of funny. There are various transcripts of that conversation online. In the early 1990s, because there's been so much interest in chat rooms and things like that, people began to get the idea that they could automate this process and provide answers to people. They use this really kind of ugly word, chatterbot, to try to describe this new technology. Obviously, that quickly got shortened down to chatbot. For those of you who played around with Microsoft and some of its early operating systems, you may remember the animated paperclip called Clippy that you could click on and ask questions, and you'd get kind of stock answers for different problems that you might have and so forth. That obviously is not terribly sophisticated. It seemed like things were more sophisticated with the advent of smart speakers like Alexa, or operating systems, obviously like Cortana, Hey Google, Siri, things like that. But again, even here, and these things all arose, by the way, in the early 2000s to the early 2000 teens. Even so, these various voice responders are pulling from a database of fairly fixed answers. And again, they're keying off of specific keywords that the programs are trained to recognize when they're listening to us speak. So for instance, if I'm in my kitchen and I ask Alexa, what is 39 degrees Fahrenheit in Celsius? The program is sophisticated enough to recognize that I'm asking it to do that calculation. Or if I've got a recipe and I have 4 people coming for dinner, but the recipe is only for 3, I can get it to do conversions, and it's going to recognize all of the necessary words within that in order to do what I'm asking. But it's not really able to generate fresh content based on the things that it hears. That really began to change in 2022, when this company OpenAI released ChatGPT 3.5, and that was really a game changer. It was just a tremendous shift in how scientists were approaching this entire problem. These are the major players right now in what I would refer to as general purpose chatbots, or general purpose generative technology models. So you've got OpenAI, which is now released version 4.0 with quote-unquote multimodal capacity, which I will get into in a few minutes. You've got Microsoft Bing, which they're building into pretty much everything they do. Google played around for a while with a version that they called Lambda, which made headlines when one of the engineers on the Lambda project actually gave a series of interviews in which he alleged that, from his perspective, Lambda was actually alive, which was poo-pooed by the vast majority of other computer scientists. And now their product is called Gemini. Um, very useful tool within the limitations of all of these tools. And so it's just interesting to see how these different companies shape their product based on their prior experience within the technology environment. You've got Meta AI, which is basically Facebook's approach to all of this. Elon Musk is trying to build a quote-unquote open source AI that he calls Grok, and that's just such a nerd reference for Elon, which will come as no great shock. But there's a famous science fiction novel by a writer called Robert Heinlein entitled Stranger in a Strange Land, and this word is something that Heinlein made up to fully, basically it means to fully understand to the core of your being. So seriously, Musk is a complete nerd. One company that is not on this list, which will be, I think, a significant player very shortly, and there may be actually developments in this before we get to the end of the course, is Apple. Apple has been devoting a lot of resources lately to the whole generative technology / AI field. And as I've pointed out in a variety of my different lectures, Apple has, basically 2 billion devices in the field, something like that, all running an integrated operating system that is completely under Apple's control. So, for instance, in later this month, actually I think next week, which shows you how fast this stuff is moving, when Apple announces its iOS 18 for its mobile devices, there's a lot of speculation about the fact that AI, generative technology, whatever flavor they've developed, will be baked in to iOS 18, which means it will instantly roll out to billions of users around the world, just instantly. So that is going to be another significant advancement in terms of the availability and the potential implications of this new technology. Let's see. One of the other things, obviously, we'll be talking about quite a bit, particularly because of our work in the educational field, is the rise of specialized chatbots or specialized tools. And, a lot of people have realized that if you are building a chatbot or a generative technology tool that is only intended to do a limited number of things, then it's much easier and much faster to develop it, to roll it out, and the program itself tends to work much more quickly. So we'll go through, particularly over the course of the next week, a variety of different tools that educators are using now, that students are using, that people should be aware of, because some of them are incredibly effective and I think really quite valuable. Obviously, nobody's doing this for free. You've got constant issues with respect to how do people make money off of these new technological developments. They're putting absolutely staggering amounts of R&D funding into these programs. And one piece of this, which actually bumps up against the ethical aspects that we'll be talking about, is that generative technology or AI tools in general are absolutely staggering users of energy. And, we've seen this before with respect to things like for instance, cyber currency, and people using farms to to basically try to generate Bitcoin and things like that. And some of them are using levels of electricity that is equivalent basically to small nations. And unfortunately, because of the way in which these programs work, you're starting to see real concern about the level of ecological impact of doing this particular technology. And whether or not that spurs developments in energy technology or energy usage, that'll be definitely something to see. But the cost factor alone of the energy is one of the things that may potentially, at least, slow down the development of this particular industry. It really is that significant a cost. The other thing that I think people really need to be aware of is that the wild interest in generative technology and the relative success of it rolling out to sectors across the economy, throughout society, is raising real concerns about the disruptive impact of this technology. And so you're starting to see, I think, increasingly aggressive efforts by administrations and legislatures, not just in the United States, but literally around the world, to try to get a handle on this before things get too disruptive or too really economically catastrophic for people. I mean, already you're starting to see significant layoffs in various low-level text generation jobs. If you spin that out, and there's significant other layoffs due to this technology, that's not in any way useful for society as a whole or for governments in particular. So I think that's going to be another area to keep an eye on, particularly if you're in school administration or if you're really concerned about developing your curricula in ways that will help prepare kids, because it's going to be really good to know what the legal restrictions and the legal parameters are of this new technology. So, in terms of the material that you'll be reading and the work that you yourself will be doing over the next few weeks, here are what I think are the basic terms that are good to understand. We'll come back to this list periodically to make sure that everybody's on the same page. These are also terms that are useful to maybe spend a little bit of time researching yourself, just to make sure that you understand how they're used, and perhaps, as necessary, getting different perspectives on how people explain them. So first, AI, and then AGI. AI is an acronym, obviously, for artificial intelligence. AGI stands for artificial general intelligence. And the distinction there is that artificial intelligence is this idea that we can have a device or a computer program that is able to replicate some aspect of human intelligence. And a lot of people refer to GenTech as AI. I mean, virtually every headline writer, journalists, you name it, it's just the common shorthand, even though it is not accurate for reasons that we'll get into, because generative technology is not capable of initiating its own thoughts, of coming up with its own prompts, of inventing things on its own. If we get to what is referred to as artificial general intelligence, and people are worried about the fact that a number of companies appear to be working on this, then that may in fact be a significant issue for us to confront. Nobody's particularly clear on how fast that might happen, but it's definitely an issue. Chatbot, that is the shorthand for the interactive tools that you can discuss with, that you can pose questions to follow-up questions, ask for edits, so on and so forth. It's really, when we talk about ChatGPT, that's what people consider to be a chatbot. Generative AI. Generative AI is really specifically what these programs are. And by that, what we're talking about is that they are tools that have been trained on large amounts of data in order to predict with often uncanny results what the next phrase or what the next word should be in any given conversation. And so they're generating, and that's where the term comes from, obviously, they're generating this text based on the statistical analysis of literally millions of pages of human writing, most of which, by the way, is under copyright, which is a whole different issue we'll get into. But the point being that it turns out that within some reasonable degree, what humans write can be reasonably predicted in a given situation with obviously some variation. And so there's randomness built into these things to help deal with that. One of the things, though, that can pop up because of that randomness and because there's ways to push these models in directions they don't anticipate, is that these chatbots, the generative AI, can produce what we commonly refer to as hallucinations, which means basically that they are providing answers that have no basis in reality whatsoever, that are simply made up in ways that we don't necessarily fully understand. And typically, I think what ends up happening is that these programs are written in such a way that they don't have the capacity necessarily to say, I don't know. And so because they don't, they tend to try to answer regardless of whether or not they actually know something is true or not. And so this is one of the reasons that every single chatbot you see will say, these answers may not be correct. You should not rely on these answers. It is fundamentally why you should not be using these programs as your medical advisor or necessarily as a physiotherapist, for sports injuries or what have you. You might get some good information. There might be a good summary to help you understand what's going on, but these are not trained professionals, and there's just a real risk that the data that comes out of it is a figment of the chatbot's imagination. Large language model is a phrase that refers to the mechanism by which these programs were educated, trained, however you want to put it. Large language model is specifically referring to this idea that you are taking vast quantities of data and you are using it to create a statistical database that can then be used by a chatbot to figure out what its response should be to a given question or prompt. Machine learning is the process by which the algorithms and the software tools use these huge piles of data to train themselves. The phrase can also refer to the process of the software or the algorithm getting feedback and then altering itself in response to that feedback. So it really is going through an educational process as it does so. Natural language processing is the idea that this software is now capable of interpreting the words that we use or the requests that we make without necessarily having to be programmed separately as to what each word might mean. And so it's just a way of illustrating that we've gotten much, much more sophisticated about how these things work. Neural network is is the phrase that refers to the actual software nodes within a large language model that interpret the language, use a statistical analysis to figure out what the next output should be, and then produce that output for the user. So you have input gets filtered through the neural network, and then you get output. Really, pretty straightforward process, with the exception of, inside the black box, it's very much like those old maps of, sailors basically just saying, "Here there be dragons," because we have no idea what's going on. And that's not entirely fair. Obviously, there are people with incredibly sophisticated understanding of the mathematics and so forth involved. But we are rapidly approaching a level of sophistication for some of these chatbots, this generative AI, where our grasp of what is taking place is really quite hazy. Prompts and prompt engineering refers to, first, a prompt is a request to a chatbot or to a generative AI for a particular output. So, for instance, if I were, as I increasingly do because I hate writing them, if I'm asking a generative AI for a course description, I will construct a prompt in which I will give the generative AI the title of my talk, the audience, where I'm giving it, and maybe an example of a previous description that I've used, and I will ask it to generate a new description based on that prompt. Prompt engineering is, quite honestly, a growing field in which people are training themselves or actually being trained on how to write the most effective prompt for a given chatbot or generative AI in order to get the best output. And there's absolutely no question that there's a technique to doing this, that some prompts are more effective than others. And, literally 2 years ago, if you had said to someone, I'm working as a prompt engineer, they would have had absolutely no idea what you were talking about because the concept didn't exist back then. But now we're in a situation where this is a rapidly growing area of specialization. We'll definitely be getting into some of the tweaking of prompts as we go through, particularly the next week. So definitely keep an eye out for that. But I have found that there are a variety of wonderful resources online, some of which I'll post next week, in terms of giving people suggestions about how to do effective prompts. And then sentiment analysis is a fascinating piece of this, in the sense that one of the things about these generative AIs that's particularly intriguing is that you can ask it to create output with a specific tone, or as if you are a particular person. And so one of the things that they're in the process of building into these various algorithms and software programs is the ability to evaluate and distinguish human emotional tones or emotional responses. So if I'm writing, if I am doing a talk, for instance, for students, I might ask for something that's more informal and more easily understood, say, by middle schoolers, whereas if I'm giving a lecture to educational professionals or to attorneys, which I often do, then I'd ask for a different tone in terms of the presentation description. So let's talk a little bit about basically what the impact of all of this is going to be with respect to schools. And we'll be delving into this in more detail over the next 2 to 3 weeks. But just as a quick introduction, I think it's worth pointing out that schools have been through this before. We've gone through the PC wave. We've gone through the web wave in the mid-1990s. Mobile devices have been challenging for the last decade and a half. So schools definitely know how to approach this. They understand the concerns that can arise. The issue that we're dealing with, of course, is that GenTech is both bigger in the sense that it is more widely available, and its uptake has been vastly faster because it is available to every single individual or student who has access to the internet in one way or the other. And because so much of it is text based, you don't even actually need a particularly powerful device in order to make use of generative technology. So the upshot is that we're seeing this being used by a much broader range of people than was true, for instance, with smartphones. I mean, when smartphones were introduced, they were obviously an incredibly cool thing and potentially powerful, but they were expensive. And so it was a lot slower adoption for those kinds of things than is true for GenTech. The other thing, and we'll certainly be talking about this constantly, is that there is just relentless development and deployment of generative technology. And companies are highly motivated to be on the cutting edge of this as developers. Potential users of the technology are incredibly interested because, and this is where the disruption is really potentially painful, generative technology on the user side is vastly cheaper than human beings. And so if you've been using, somebody to summarize transcripts, for instance, in a law firm, paying a paralegal $40,000, $50,000 a year or whatever to do that, now you can feed those transcripts into a generative technology and get a good, reasonably reliable summary of that transcript in seconds for basically no cost. And that's the kind of thing that really has policymakers up at night trying to figure out how far is that going to go and what are the implications for society as a whole. And the sad thing is, at the end of the day, we just don't know. We don't know how much of an impact this will have, how fast it will happen. All we know is that the potential is huge, and it is happening very quickly. All right. Most of you are aware of this, but it is always good to remind people that it's not just a question of when GenTech will show up in your school. It's how do you deal with the fact that it is already there? As one U.S. Department of Education official put it, there's no sitting this one out. I mean, the kids love GenTech for a variety of different reasons, some good, some bad. They are all over this. A lot of your colleagues, maybe you, are exploring the different ways in which these tools can be used. This is absolutely showing up. It is like waves on a beach. It's going to be here. We need to figure out, basically, as best we can, what the implications are for the schools and what is the most rational response given the changing world that our kids are entering into. As I said, kids are using this. They'll keep using this. We are just scratching the surface of what the next 15, 20 years are going to bring when you think about the fact that this year's kindergarten students are graduating in 2036, which is absolutely mind-blowing. I had a granddaughter who showed up 18 months ago, so that was October of 2022, which means that she's going to graduate from high school in 2040. It's daunting to think about what the shape of the technological world will be. But the best we can do right now is to be aware of how this is evolving and get as many people on board with the planning as is possible. And to be realistic, that it's going to take a while for us to really understand what the impact of all of this will be. Okay, broad ethical concerns. I just wanted to lay down a few markers before we get to this in weeks 3 and 4. We've got issues with respect to privacy at all levels of a school. Student privacy is obviously the big one, but there are a bunch of different issues that educators should be aware of. There's going to be potential FERPA violations that administrators have to keep in mind. A variety of different things for us to discuss. We've got, on top of that, significant risk of misinformation and student misuse. Just as a reminder, in case any of you have forgotten, we're heading into an election year. It's going to be a little bit challenging, and a lot of people are saying that this will be kind of the AI election. And we don't know what the implications of that are going to be. So it's going to be interesting to watch. For those of you who teach civics or history, a wealth of topics to cover and discuss. Student misuse is a little bit more disturbing. When we talk about the student ethical issues, we'll be talking about things like deep fakes. We'll be talking about tools that are used to harass students in one way or another. And this becomes, I think, part overall of our digital citizenship education, which is really a core piece of this. As with every technology, even though this is more widely accessible, we do need to ask ourselves, is there equitable access to this technology, to its benefits, to its resources, and so forth, or are we creating structures that make it hard for people to produce the same results because people have different access to different tools? I think one of the things that's worth pointing out to students is that, yes, even though you can get a serviceable poem out of a generative technology tool, that's not quite the same thing as learning how to do a poem yourself and to come up with your own metaphors and your own rhyming scheme and things like that. It may be that you would collaborate with the generative technology as an editor, or potentially as a writing partner in different ways. And there's a lot of, I think, valuable ways in which that can roll out. But helping students to really understand the innate benefit of learning to do a particular skill is really, I think, increasingly important. I mean, as people will point out, there's no need for me to make my own pizza, particularly in Brooklyn. But, it's fun. It teaches me a variety of different skills. And yes, I could go down the street, but then it's not quite the same. And so that's a very simple version, I think, of a very complicated conversation to have with students. But hopefully it's something that they're willing to think about and be receptive to. We always, I think, are concerned, given what's taken place over the last half century, with the role of technology in terms of face-to-face interaction. Absolutely a concern, and we really need to make sure that that's at the forefront of our discussions. And then lastly, this is a phrase I think that comes up all too often. We suffer, as ever, from general fear, uncertainty, and doubt about how these things will play out. And one of the things that I really hope that this course will do is, by familiarizing people with the technology, reduce some of the uncertainty, reduce some of the fear that might be associated with it, and really underscore the potential benefits, as long as we are thoughtful about the risks and the potential harms that can also result. So with that, I'm going to close out the first of these 4 presentations. I certainly encourage people to reach out if you have any questions, if there are any issues that you think need to be further explained, and I look forward to working with everybody over the weeks to come. Thanks.